So let's get started with the next problem. The problem says merge two sorted list, and it's an easy one. Merge two sorted list and return it as a new sorted list. The new list should be made by splitting together the nodes of the first two lists. So let's say it's given 1, 2, 4, 1, 3, 4. We compare 1 and 1, so we can take either because they're both the same. So we'll take 1, then the next one, then between 2 and 3 we'll have to choose 2, then we go to 3, between 4 and 4 it doesn't matter. So let's get started. In the first case, I always like to cover the base case, which would be L1 is null and L2 as well is null. In that case, we would simply return a null value. Now, the next step should be creating a result node. So let's say result, or let's call it something interesting. Let's call it sorted list is equal to new list node. And let's create some any temporary value 0 to get started, because at the end we will be returning the next of the head. And as we are going to keep moving the node to the next and next and next, we're going to keep iterating and adding nodes to the current one. We will lose where it started, and at the end we have to return the head from where it began. So let's create a list node called a dummy, and that would directly point towards the head of the sorted list. Now, as long as L1 does not equal to null and L2 does not equal to null, here we have to make sure that they are both not null, because if one is null or the other, we can just append the remaining nodes of the list to our answer. So we have to make sure that they are both not null. In that case, we can just keep adding one by one nodes. So let's say if L1.value is less than L2.val, in that case, or let's make it equal, because even if they are same, we don't care because it's pretty much the same. You take whichever one the first. So let's say L1's value is smaller, that means that needs to go first in our result. So our sorted list dot next would be a new list node with the value of L1.val. At the same time, we would be updating L1 to the next pointer because we have already accounted for the first value. If it's not less than or equal to, there is only one possibility, that it's greater. So L2 has the higher value. In that case, what we would do is sorted list dot next is equal to new list node with the value of L2. And now that we already accounted for the value, we will update L2 to its next pointer. L2 is equal to L2 dot next. Now that we accounted for both, we still need to move our sorted list to the next pointer because we already counted the first value. Is equal to sorted list dot next. Alright, now that we are done with this views, at the end, let's say we already accounted for most of the nodes, but at the end, let's say L1 is of length 3 and L2 is of length 6. So we accounted for 3 and 3 values, but L2 has still 3 more values. So sorted list dot next should be, we will check if L1 is equal to null. If it's null, that means there is might be something in L2. If it's not, then definitely it's going to be null, which is by default going to be null, so it doesn't matter. And if it's not null, then we'll just add L1. So this way we can cover for all the remaining nodes that are remaining in either of the nodes. Now that we are done with this, we will just simply return dummy.next node, which should always point to the head. And let's see. Ooh, it's equal to L1 is equal to null, then cannot find symbol. Ooh, it's a spelling mistake, so it's gonna be sorted list.next. My bad. And if we submit, alright, so that's merge to sorted list, and it's an easy one. As you can see, it's straightforward. All right, thank you, have a good day.